all the calculations and visualization so far brings us to a very exciting and alternative perspective on what we were doing here, what's happening here in the logistic regression. So you remember that we had some dots representing the probabilities, and we were trying to fit a logistic curve on these dots. But what happens if we only plot the log of odds instead of probabilities or odds? So as you can see, we have 4 points here. Now, can you guess what happens if we connect them? Yeah, they really look like a line here. Now, why is that? So if we go back to the visualization part and remember what we were trying to do before, we guessed this general format for this equation, and we used to play with beta 0 and beta 1 in order to mimic the behavior of this curve. Say, for example, first we would decide how steep we want our curve to be, and then let's say, for example, this is enough, and then we would bring our curve to the left or right in order to fit our points. So this is very crude. This is a very crude approximation of that curve. Now, let's go back and this time see while we were doing this, what else were we doing unconsciously? Let's plot log of odds as well as probability function as well. Now, we're going to do the exact same thing again with this black curve, but we'll see unconsciously what we're doing with this blue line as well while doing that. So then again, let's estimate how steep we want our curve to be, the black curve. And then let's bring it back. So what we were doing was focusing on this black line, or this black curve, but what we were doing at the same time without knowing this was trying to approximate the log of odds with this line, with this blue line. Why is this even important? Because instead of answering a very difficult question of coming up with beta 1s and beta 0s in order to build this complicated probability formula to fit some probability points in space, we can transform the question into a much easier question. So we have some points representing the log of odds instead of probabilities, and then we're just looking for the best line that fits these different points in space. So just to test that hypothesis, let's actually run a regression on these 4 points. As you can see, this orange line is a very good approximation of the line of best fit passing through these points, which are log of odds. Now, the coefficients here are very close to the beta 1 and to the beta 0 we found before, a very large beta 1 and very large negative beta 0. The reason I personally find this a very interesting perspective is that we can transform a complicated problem of fitting an S-shaped probability curve with a much easier problem of fitting a straight line. But of course, we have to convert the data from probability values into log of odds. The resulting beta 1 and beta 0 would still have the same values with the same meanings as before.